Hello everyone. So today let's solve the problem number 213, house robber 2. So we have already solved the house robber 1, right? So let's solve the house robber 2. So this is easy one. Let's solve this one very quickly, right? So uh, let's see what the question states here. Just give me a second here. Yeah, let's see what the question states here. So suppose you are a robber, right? Just consider, man. Don't be a robber actually. Suppose consider you are a robber who is planning to rob the houses arranged in a circle, right? Suppose you are a robber planning to rob houses arranged in a circle. Just keep this in mind. So this is very important point of this question basically, right? So suppose you are a robber planning to rob houses arranged in a circle. Adjacent houses trigger the alarm if both are robbed. Again, adjacent houses trigger the alarm if both are robbed, right? So given nums, see here, we have been given nums, right? That consists of the integers basically within the array. Given nums, nothing but money at each house, right? So this is money at the first house 2, money at the second house 3, money at the third house 2. This one we have to return the maximum amount we can drop without alerting the police, right? So just keep this in mind. Given nums, we have to return the maximum amount we can drop without alerting the police, right? So suppose for example, nums equals, so we have been given 232 here. So output is 3 here. So we cannot rob the house 1, that is money equals to, and then the this one, rob house 3, right? uh, Basically, right? So money equals to 2, where money equals to 2. They are adjacent houses. So this is in the form of circle. See here. Let me write this one like this. See, suppose it is in the form of circle, right? So first we have the value 2, and then this one. Suppose it is like this. Suppose we consider in this way, right? So this is 2, and this is 3, and this is 2, right? So this becomes adjacent to this one, right? As it is in the circle, this becomes adjacent to this one. We cannot rob this particular 2, and this we cannot rob this these two, right? These two houses basically, which consists of the money 2 and 2 respectively, right? So if we consider this one, we can't consider this one, the last one basically. If we are considering the first house, we cannot rob the third house as it is circular. So that is the reason while reading the question I said that this one, suppose consider you are a robber planning to rob the houses arranged in the circle. So this is the thing. So that is the reason I stressed, right? So this one, let's consider 3 here, right? So suppose we this one, ignore this one, and suppose we rob this house, right? So this will be 3 actually, right? So this will be 3, right? We can, the highest amount that is stashed in the houses, uh, this one, the robber can rob here as 3 in this case, right? So we got the output 3, right? So same goes with the example 2 as well, man. See here. So suppose let me give you a circle. So let me go with 1 here, then followed by 2, and yeah, 1 followed by 2 followed by 3 followed by 1 again. So here, uh, we cannot, suppose if we consider 1 here, we cannot rob the next house and nothing but the adjacent house. Then we have to rob this one, right? So here this will be this one. What do we call 1 plus 3? So this will be the maximum itself, right? So yeah, this will be 1 plus 3. So this will be 4. So here they have given 4 itself, right? So 4, 4. Same goes with the example 3 as well. So they have given us wonderful examples just for the sake of understanding. Now let's do one thing. Let's this one. Let's discuss the approach followed by the complexities, and then let's write the code. The first thing I have to tell you is we will be making use of the DP here to solve this particular problem, right? So let's go with the first point here. Let's go with the first point. Now, because houses are in the circle, we are discussing the approach, right? So because houses are in the circle, we cannot take both first and the last at the same time. So we are considering this example, first example. So as we are considering how this one circle, right? Houses in the circle. So let me draw this one again. 2, 3 as well as 2. We cannot consider first and the this one. what do we call first and the last one basically, right? So first and the last one, this one, sorry, if I showed you if I had showed you the third one, yeah, this one actually. Now we have written from this side, right? And this one anti-clockwise. So this is fine. Now suppose uh yeah, because houses are in the circle, we cannot consider first and the last at the same time. So let's consider two linear cases here. Suppose the first linear case is robbing the houses from index 0 to n minus 2. Exclude the last here. First point here is robbing the houses from index 0 to n minus 2, right? The second point here is rob the houses from index 1 to n minus 1. 1 to n minus 1. This is simple. Yeah. Now for each linear segment, use 1D DP where DP of I equals maximum maximum this one maximum money robbing up to the house I in that segment, right? So now let's consider the example. We have 232 here, right? So we have 232 here, nothing but nums we have been given 232, right? We are consider the first example, right? Now case A is exclude the last, right? Exclude the last. Suppose we exclude the last, this one. Now we will be considering actually 2 comma 3, 2 comma 3, right? So this DP yields max of 2 comma 3 will be going with max of 2 comma 3, right? So now the answer will be quite obviously max of 2 comma 3 is 3, right? So case B is exclude the first, meaning this one we have to exclude, this one we have to consider this time. So this one will be 3 comma 2, this one, right? So this will be 3 comma 2 again. So we will be going with max of what do we call 3 comma 2 here, right? So DP yields max of 3 comma 2, which is again 3, right? So here, answer or the result here is max of max of this one, basically this one and this one. So here it will be max of 3 comma 3, which is 3, right? So this we will return this one as output. The output that we got here is this one 3, which is equivalent to the output that they have mentioned for the example 1 within the question, right? Now our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities. So what will be the time complexity here? The time complexity will be big of n and the space complexity would be big of n as well. Time complexity will be big of n because we'll be scanning the array a constant number of times here. So we'll be going with the two linear DP passes. Let's see that one while we write the code, right? So one more thing, what will be the space complexity here? The space complexity would be big of n as well because each linear call uses 1D DP array of length up to n. So time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. Now, as we are completely familiar with the approach, let's do one thing. Approach and the complexities. Let's start writing the code basically. Now, first, if there is only one house, we can just rob it. That's the base case. So I'll just go with if length of the nums is equivalent to 1, then we have to rob this one, first house, which is present at the first index. Now we have to compute the two linear cases, right? So one is excluding last and another one is excluding first, right? So this one will be int n equals nums dot length. This is fine. So here let's leave this one man entirely. Now let me come out of this one. So yeah, first let's go with a helper function rob linear, right? So let's go with a 1D DP on the linear range L to R, nothing but left to right inclusive, right? So I'll just go with here private int rob. Let me name this one rob linear here. This is fine. I go with int here nums and also int left comma int right. So this is fine. First, let's go with the length of the segment here. This one will be length equals R minus L plus 1. The second one would be if no houses in the segment, then we have to return 0. Then I'll just go with if length less than or equal to 0, then we have to return 0. Right, now let's go with the base cases for the 1D DP. Suppose let's consider only first house in the segment and also the single house segment, right? Single house segment that is done basically. So let's go with the base cases for the 1D DP. So I'll just go with a DP of 0 equals nums of left, nothing but only first house in the segment. Now we have to go with a single house segment that is done. So if len equals 1, then we have to return dp of 0, right? So this is fine. For the second house in the segment, we have to choose the max of first or the second actual values, right? So I'll just go with accordingly with the approach that we have discussed. So this one dp of 1 will be mat dot max of nums of 1 along with the nums of l plus 1, right? So this is fine, man. Now let's do one thing. Let's fill the DP array for the rest of the segment, man. So let's go with the for loop here. For int I equals to 2, I less than length. So this one will be less plus. So within the for loop, what shall we do? Let's either skip the current house, nothing but the DP of I minus 1, or rob it and add DP of I minus 2. So this is simple, man. DP of I equals, so this one will be math dot max of dp of I minus 1, uh, dp of I minus 2, 2 plus nums of this one, left plus 1, left plus I, it has to be, not 1, sorry. Yeah, now this is fine. Let me come out of this one entirely. Now we know that dp of length minus 1 will hold the max for the segment left to right, right? So we can just return here dp of length minus 1, right? So where we'll get the output basically. Now let's come to the, we are done with our rob linear, this one, what do we call, helper method. Now let's make use of this one, rob linear helper method within the main method, nothing but the rob, right? So I'll just go with here max 1 equals rob linear, this one, nums comma 0 comma n minus 2. So this is fine. In max 2 equals rob linear, this is fine, nums comma 1 comma n minus 1. Yeah, so we are just robbing the houses from 0 to n minus 2. Also we are robbing the houses from 1 to n minus 1. So finally answer is nothing but the maximum of the two exclusive cases, right? So that's what we saw in the approach as well, right? So we have to go with the max finally, right? Of max of two exclusive cases basically. So I'll just go with return mat dot max of. So here this will be max 1 comma max 2, right? So this is fine. Let me format the code once and let me hit the run button. So this is it for the code. Simple one, right? Yeah. Mm, this one error, cannot find the symbol. Where dp of here dp of 0 I have considered. So this one has to be nums of L, which is correct actually. So here, didn't I consider within the parameters? I have considered, right? Intel, Intel, int R here. Cannot find the symbol dp. One second. If I have not initialized dp this one, array here, length less than or equal to 0, I have returned 0. This is fine. Oh, here I have forgotten to initialize the DP. So basically we have to go with the DP of Y that will DP of I that will represent max money for the segment house index, right? That's relative, right? So basically I can just initialize DP to new int of size length here. Let me format the code and let me hit the submit button directly this time. So I hope this works for all the test cases, man. Wrong answer. Code once here. What's wrong here? 1 second. So what mistake I've done here is in the line number 24, DP of 1, we are this one going with a mat.max of nums of not 1 actually, nums of left comma nums of left plus 1. So let me format this one again and let me hit the submit button directly this time. So this time it has to work. Let's see. Yeah, all the test cases are getting passed. So whatever the code that we have written works absolutely correct. So this is pure 1D DP, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.